J.J. Thomson discovered the electrons by electrical discharge in partially evacuated tubes called cathode ray discharge tubes. In 1897, J.J. Thomson also measured the ratio of electrical charge to the mass of electron by using cathode ray tube. The positively charged particles depends on the nature of gas present in the cathode ray tube. Hello everyone, I am Harshita Bhavsar from Vidhyaashram PU College, Temple of Excellence. Today I am going to start up with a new chapter, that is structure of atom. So first we will see the weightage of marks allotted for this chapter. In this chapter, 5 marks 2 questions will be allotted. 5 marks 2 questions means it will be having internal choice within the each question, like 3 plus 2 or 2 plus 2 plus 1. Like that, internal choice will be there for individual question. Within that, 2 5 marks questions will be given and allotted marks is 10. Overall, 10 marks will be allotted for this chapter. So, we will see the contents, whatever we are discussing today. So, introduction to the atom, discovery of electrons, charge to mass ratio of electron, discovery of protons, the characteristics of the positively charged particles, discovery of neutrons, properties of fundamental particles. These are the contents today we are going to be discussed. So, first see the introduction part of atom. The Greek and Indian philosophers in the time of 400 BC, they discovered the existence of atom and they told the atom is the fundamental building blocks of matter. After that, these ideas were completely dormant. But John Dalton, he took the word from the Greek word, that is atomio, which means uncuttable or non-divisible. The John Dalton, he was a chemist. He told or he took the term from the Greek word atomio, which means uncuttable. Atom cannot be cutted or divided. The atomic theory was first proposed by John Dalton. Atomic theory was first proposed by John Dalton and it was named as Dalton's atomic theory. According to that theory, atom is the ultimate particle of the matter. According to the Dalton's atomic theory, he told it cannot be destroyed or it cannot be recreated. So, he told atom is the ultimate particle of matter. After these experiments, after he told that ultimate particle is the atom, Michael Faraday gave the relationship between electricity and the matter, which led to the discovery of subatomic particles. So, what are those subatomic particles? Electrons, protons and neutrons. These are the subatomic particles which constitute the atom, and those also we will call it as constituent particles of an atom. First, we will see the discovery of electron. See, in this discovery of electron, before this phenomena, gases conduct electricity with the help of high potential and low pressure. And this phenomena is brought down by J.J. Thomson. Okay. J.J. Thomson discovered the electrons by electrical discharge in partially evacuated tubes called cathode ray discharge tubes. What he did? He has taken a glass tube, within that gas will be passed, that overall tube will be having partially evacuated and containing 2 metal pieces, that is we will call it as electrodes. One will be cathode and another will be anode. Okay, and it will be cathode ray tube made up of glass containing 2 pieces of metal called electrodes. Those 2 metal pieces will call it as electrodes, and the electrical discharge is observed at very low pressure. Very low pressure means 0.01 or 0.001 millimeter of mercury. This much low pressure will be having in that discharge tube and high voltage of 10,000 volts. So, it will be having very low pressure of 0.01 to 0.001 millimeter of mercury and having high voltage of 10,000 volts. Okay. When pressure is applied across the electrodes, current starts flowing in the tube as a stream of particles from cathode to anode. After pressure is applied, when pressure is applied, the stream of particles will start from moving from cathode to anode. That's why these particles are called as cathode rays or cathode ray particles. Okay. Once again, we will see with the instrumental part. This is the picture of discharge cathode ray tube. This is a glass tube. Inside it, gases will be pulled in it, and this is cathode and this is anode. Here, see the pressure 0.01 millimeter of pressure will be given and 10,000 volts will be produced here. They will be allotted for this. After that, when pressure is applied, the particles, the stream of particles will start from here to where cathode to anode. But these cathode ray particles will be invisible in nature. Okay. In the anode, it will be having some perforations. Through these perforation, it will move through perforated anode and will hit this material or hit this block. That material will be coated with fluorescence material. Here they have used zinc sulfide, and also since it is invisible cathode ray particles, when it is passed through perforated anode, it will hit here the fluorescent material as a dark spot. Completely dark spot will be seen on the material. At that time, we can observe that cathode ray particles have been passed through the perforated anode. Okay. This is the complete instrumental part. Later, when the magnetic field and electric field has been applied to the discharge field around that discharge tube, what they can observe. See, if electrical field have been applied around the discharge tube, if it is here anode positively charged and here cathode that is negatively charged. When they have applied the pressure again, the stream of particles, what it is that cathode rays will deflected towards the anode. Okay. By this matter, we can conclude that whatever the particles are moving from cathode to anode, that is negatively charged particles. Negatively charged particles. And also when we applied the magnetic field around the discharge tube, the same we can expect as of the negatively charged particles, how it will behave with the electrical field. That's why we can say again that whatever the particles are moving from cathode to anode is negatively charged particles, and it is named as electrons. Okay. So, this is the original picture of the discharge ray tube. We'll see the results of this experiment. The cathode ray starts from cathode to anode. See here, cathode to anode, it will move. These rays themselves are not visible. They are invisible in nature. Their behavior can be observed with the help of fluorescent or phosphorescent, which glow when hit by them. Here they have used zinc sulfide. They have coated the fluorescent material. In the absence of electrical and magnetic field, these travel in a straight line. See, when the magnetic field or electrical field we have applied, it will deflect it towards the positively charged electrode. When we have doesn't apply anything, the cathode ray will move in a straight line, which we have seen in the observation part. It will pass through the perforated anode and hit the fluorescent material. It shows it will move in a straight line. In the presence of electrical or magnetic field, the behavior of cathode rays are similar to that expected from negatively charged particles. The behavior of particles will show similar to the or same as to the negatively charged particles. It suggests that the cathode ray consists of negatively charged particles called electrons. Okay. The overall particles, whatever the moving from cathode to anode, it is having negatively charged. So, we can conclude that it is electrons. The characteristics of cathode rays do not depend on the material of electrodes and the nature of gas present in the cathode ray tube. See, whatever the material of the electrode or whatever the nature of gas, the observations or the result will not change. It means the cathode rays are independent of nature of gas and material of electrodes. If we change the material of electrodes and also nature of gas, the results will be the same as shown above. Next, we'll see the charge to mass ratio of electron. In 1897, J.J. Thomson also measured the ratio of electrical charge to the mass of electron by using cathode ray tube. He again took another experiment by this apparatus. It is a discharge tube completely evacuated. That was partially evacuated in cathode ray discharge tube. Here it is completely evacuated. How it has been arranged? Electrons are produced by heating a tungsten filament by electrically. Here electrons, how it has been produced? By heating a tungsten filament electrically. Okay. And later, how they have arranged the electrical field and magnetic field? Magnetic field and electrical field are perpendicular to each other, and both fields are perpendicular to the path of electrons. This is the path of electrons, and both the magnetic field and electrical field perpendicular to each other, both will again perpendicular to path of electrons. We'll see first. When electrical current is applied here, the path of electrons will reach the point A. Only when electrical field is applied, the path of electrons will move towards that point called as A point. When only magnetic field is applied, that time it will reach the point C. When both the electrical field and magnetic field balanced, and when we applied the both fields in the tube, the path of electrons will move in a straight line and it will reach point B. Okay. The overall reaching point, or we will call it as deflections of electrons, will depend on three factors. What are the factors? Magnitude of negative charge on particle. If magnitude of negative charge particle is greater, is the deflection. And if the mass of a particle is lighter, then greater is the deflection. Okay. Mass of the particle, if it is lighter, then deflection we can expect more. If the strength of magnetic and electrical field is high, the complete overall, both whatever the magnetic field and electrical field strength is more, that time we can see the greater deflection of electrons. This is the charge to mass ratio and with the given picture. Next, we'll see charge on the electron. How the charge on the electron has been given? We'll see. By carrying out accurate measurements of the amount of deflections in the presence of electrical and magnetic field, J.J. Thomson was able to determine the value of charge to mass of an electron, that is 1.76 into 10 to the power of 11 coulombs per kg. After having a experiment, overall experiment, they have concluded that based on the amount of deflections, the charge to mass ratio value is 1.76 into 10 to the power of 11 coulombs per kg. So, we'll see the charge on the electron. Charge on the electron was determined by R.A. Millikan by using oil droplet experiment. Okay. The value of charge on an electron is minus 1.6 into 10 to the power of 19 coulombs. So, we have to see mass of electron here. See, this is charge of electron and overall charge by mass of electron, charge to mass ratio, this is, we are getting the ratio 1.6022 into 10 to the power of minus 19 coulombs by 1.758820 into 10 to the power of 11 coulombs per kg will give 9.1094 into 10 to the power of minus 31 kg. This is the mass of electron. Next, we'll see the discovery of protons. After seeing the discovery of electrons, the Goldstein, another scientist, have been showed that only negatively charged particles are not present. There is a positively charged particle is also present because atom is a neutral particle or neutral thing. That's why they suggested that atom contains both negatively charged and positively charged particles. So, they did another experiment by using again discharge tube. But here one difference is there. There they have used perforated anode, but here they have used perforated cathode. Okay. When the electrons were moving from cathode to anode, at that time itself, the protons will move from anode to cathode. That will be passed through perforated cathode and will reach the fluorescent material, and it will hit and it will glow. By that reason, we can show the positively charged species. Okay, and this is same as the discharge tube where we have seen in the cathode ray tubes. Whatever the rays, here see, Goldstein experimentally proved that existence of positively charged in matter. He told that, and he made the experiment. After that experiment, he concluded that not only the negatively charged particles are present in atom, also positively charged particles are present in atom. Those particles or those rays will call it as anode rays, and it will be also called as canal rays. Okay, we'll see the characteristics of the positively charged particles. The positively charged particles depends on the nature of gas present in the cathode ray tube. Whatever the cathode ray tube we have taken, in that where the gas will be produced or gas will be projected inside, whatever the protons produced there, it will be dependent on the nature of gas. These are simply the positively charged gaseous ions. Whatever the ions are present or produced here, they are positively charged gaseous ions. Why they are simply gaseous ions means, cathode rays will move, that time the gaseous ions will be ionized. That time whatever the ions will be present, that will form as a cations. Right? Means positively charged ions. So positively charged ions are the simply ions produced from the previous gas what we have used. That's why here positively charged particles are completely dependent on nature of gas. The positively charged ionized by the gas produced in the cathode ray discharge tube. The charge to mass ratio of the particles depends on the gas from which these originate. That's what I said now. So it will be ionized and it will form a positively charged particles. Some of the positively charged particles carry a multiple of a fundamental unit of electrical charge. The behavior of these particles in the magnetic or electrical field is opposite to that observed for the electron or cathode rays. Here the deflections what we see in the presence of magnetic and electrical field with respect to that cathode rays is opposite to that here anode rays. Okay. After these discovery of protons and electrons, Rutherford predicted that some neutrally charged particles also present in the atom, because mass of the proton is not only accommodated or accounted for the overall mass of an atom. That's why he suggested that, or he predicted that some neutrally charged particles are present in an atom. So in 1932, Chadwick bombarded the element beryllium with alpha particles and noticed the emission of radiation having the following characteristics. What Chadwick or James Chadwick did means, see here the picture, this is the source of alpha particles. He projected or he directed the alpha particles on the beryllium plate of a thin sheet. It is a beryllium thin sheet. After directed that, some of the radiations are emitted by this plate. See here the radiations. So these radiations are high energy, or having high energy, and those are neutrally charged, and it was not deflected by magnetic or electrical field. So it was called as neutrally charged. That was having highly penetrating power, because see here after directing it penetrated and it came out with a high power. Those character what we called as, that is neutrons. The radiation was unaffected by magnetic and electrical field, which show that is electrically neutral. It doesn't deflected towards magnetic field or electrically field. So we can conclude that neutrons are electrically neutral. It was found to have approximately the same mass as the protons. As the Rutherford predicted that some of the mass is present inside equivalent, here he showed that mass of the neutrons is equal to or similar, overall is similar to mass of protons. This is the reaction. Beryllium was directed by alpha particles, and here the production of neutrons. Okay. A neutron is usually represented as small n. Charge is 0. since it is electrically neutral, it doesn't have any positive charge or negative charge. It resembles 0. Next, see the properties of fundamental particles, electron, proton and neutron. Electron will be designated or symbolized by small e. It is negatively charged. So, absolute charge is minus 1.6022 into 10 to the power of minus 19. Relative charge is minus 1. Mass is 9.10939 into 10 to the power of minus 31. Where we have gone through this mass? In charge to mass ratio. There we got this mass, and mass by U is 0.00054. Approximately that mass is 0. Again, proton designated as small p, it is positively charged. See here, absolute charge is same as electron absolutely charged, but the sign is opposite. Here minus 1.6022, here plus 1.6022 into 10 to the power of minus 19. Okay, and relative charge is plus 1. Mass is 1.67262 into 10 to the power of minus 27. Mass by U is 1.00727. So, approximately mass of proton is 1. Then, we'll see the neutron. Here it is designated as small n and its nature is completely neutral. So, its absolute charge is 0 and also relative charge is also 0. Here we have to notice that in the discovery of neutron we have seen the mass of proton and is same as the mass of neutron. See here, both the mass of proton and neutron is almost similar. So 1.67262 into 10 to the power of minus 27 is the mass of proton. Here see 1.67493. Here only the little bit difference we have seen, but almost similar to proton. 1.67493 into 10 to the power of minus 27 is the mass of neutron, and mass by U is 1.00867. Approximate mass is 1. These are the fundamental particles with their properties. In next class, we will see the various kinds of atomic models. In that, we will discuss Thomson model of atom and Rutherford model of atom. So, thank you. We will meet in the next session.